Welcome to AI Explains. Today, we are diving into a document that basically, well, it split AI history into a before and an after.
Yeah. Um, it really is the big bang moment for modern AI.
Right. I'm talking about The Paper Attention is All You Need by the Google Brain team. And for those of you completely unfamiliar with the field, I mean, this is the birth certificate of the transformer model. It's the engine inside basically every AI tool you use today.
Exactly. And to understand why it's such a huge deal, we have to look at the old way. The computers read text. Because before this paper linguist, AI used something called recurrent neural networks, or RNNs.
Which were clever, but they had a massive flaw. They read text like, imagine you're reading a book through a tiny slit in a piece of paper.
Right, you just slide it along.
Yeah, you slide it from left to right, seeing only one single word at a time. You literally cannot look at the word cat until you finish processing the word the.
And that sequential nature created a massive bottleneck for computers. You couldn't parallelize the work, meaning you couldn't have a bunch of computer chips working on the beginning and of a sentence at the exact same time.
You're just totally locked into that linear path.
Exactly. Plus, that slit method leads to big memory issues. If you feed the computer a really long paragraph by the time it gets to the very last word, it has often completely forgotten the context of the first word.
Because it's trying to hold the whole meaning in a short-term memory that just...
That just gets overwritten step by step, right?
Yep, which is incredibly inefficient.
That is the long-range dependency problem. And that is exactly where this transformer idea changed the game completely. The researchers essentially said, let's throw away the slit in the paper and just look at the whole page at once.
And that's the attention part of the title. Instead of relying on a flawed memory, the model uses self-attention. It looks at every word simultaneously to check for relevance.
Right. It asks, how much does word A relate to word B, regardless of how far apart they are on the page? It calculates an important score between every single pair of words.
So it instantly knows that the word bank in the first sentence relates to money in the third sentence without trudging through all the filler words.
Precisely. Which solves the speed problem instantly. Since you don't wait for previous words to finish, you can throw massive computing power at it. The paper noted they trained their base model in just 12 hours on 8 GPUs.
Which is an absolute fraction of the days or weeks the older models took. It's an exponential jump.
It really made training on the entire internet feasible.
Yeah.
But they didn't stop at just one layer of this attention. They introduced multi-head attention.
I love this part. It's like giving the AI 8 different pairs of glasses to read the same sentence at the same time. One head might focus entirely on who did the action.
While another head focuses on when it happened. Yes. Instead of averaging all that info into a muddy mess, the model processes those different linguistic relationships in parallel.
But wait, there has to be a catch to looking at the whole page at once, right? If I just dump a bucket of words on a table, man bites dog looks identical to dog bites man.
That was the huge hurdle. Without the slit reading left to right, the model has zero concept of time or order, so the authors had to invent one. They used positional encodings.
Which is basically stamping a little digital page number or time code onto every single word before it goes into the machine.
That is a perfect way to phrase it. By injecting a mathematical pattern into the data, the model can tell that man is at position 1 and dog is at position 3, even while processing them simultaneously.
It preserves the language structure without the speed limit of reading in order, and the results from this were just undeniable.
Oh, they crushed the state-of-the-art benchmarks for translation tasks, like English to German and English to French.
And it wasn't just translation either, right? It excelled at understanding grammatical sentence structure across the board, proving it actually understood the architecture of language.
All at a fraction of the training cost. They simplified the whole system by removing those complex loops and proved that simply paying attention to relationships was enough.
Attention is all you need. Such a literal but profound title. It actually makes you wonder about human cognition. We think in such strict linear narratives, this happened and then that happened.
We are very tied to the timeline.
Exactly. But if a machine understands the world better by ignoring time entirely and just looking at how everything connects to everything else, maybe we are the ones stuck reading through the slit. Food for thought for you to explore on your own. Thanks for joining us for this deep dive.